The next scenarios use your familiarity with rational square roots to help you learn how to simplify square roots that are irrational. 31. Simplify each product as much as possible. Analyze the results as you work through each column. Part A, the square root of 4 times 9. 4 times 9 is under the square root, so you can multiply 4 times 9 to get 36. The square root of 36 is 6. Part B, the square root of 4 times the square root of 9. The square root of 4 is 2. The square root of 9 is 3. 2 times 3 is 6. Oh, the results are the same. Interesting. Part C, the square root of 25 times 4. 25 times 4 is underneath one radical, so we can do 25 times 4 and get 100. The square root of 100 is 10. Part B, the square root of 25 times the square root of 4. The square root of 25 is 5. The square root of 4 is 2. 5 times 2 is 10. Again, we get the same result. Part E, the square root of 16 times 25. Let's multiply 16 times 25, and that's 400. So the square root of 400, the square root of 400 is 20. Part F, the square root of 16 times the square root of 25. The square root of 16 is 4, times the square root of 25 is 5. 4 times 5 is 20. We get the same result. Part G, the square root of 16 times 9. Let's find 16 times 9 first. That's 144, and the square root of 144 is 12. Part H, the square root of 16 times the square root of 9. The square root of 16 is 4. The square root of 9 is 3. 4 times 3 is 12. Same result. So you can see in 31, if we take the square root of 4 times 9, or the square root of 4 times the square root of 9, the results are the same. If we multiply numbers under one square root, or we take the square root of numbers separately and then multiply them, we're still getting the same result. Let's look at this again in number 32. Simplify each product as much as possible. Analyze the results as you work through each column. Part A, the square root of 16 times 4. 16 times 4 is 64. The square root of 64 is 8. Part B, the square root of 16 times the square root of 4. The square root of 16 is 4. The square root of 4 is 2. 4 times 2 is 8. Part C, the square root of 100 times 49. 100 times 49 is 4900. And the square root of that is 70. Part D, the square root of 100 times the square root of 49. The square root of 100 is 10. The square root of 49 is 7. 10 times 7 is 70. Part E, the square root of 36 times 64. First, find 36 times 64. That's 2,304. You can use a calculator for that, that's okay. And now use a calculator to find the square root of 2,304. You probably don't have that one memorized. It's 48. Part F, the square root of 36 times the square root of 64. The square root of 36 is 6. The square root of 64 is 8. And 6 times 8 is 48. Part G, the square root of 81 times 25. 81 times 25 is 2,025. You can use a calculator to find the square root of that, unless you have it memorized. It's 45. Part H, the square root of 81 is 9, times the square root of 25 is 5. 9 times 5 is 45. So once again, if you multiply numbers first, and then take the square root, you get the same result as you do if you take the square root of them separately and multiply. And that doesn't really matter what order you go in part A and B, but when you look at something like part E, 36 times 64 is pretty hard to multiply. But if you look at them separately and take the square root separately, the numbers get smaller, and then it's easy to multiply 6 times 8. 81 times 25, that's a big number, 2,025. But the square root of 81 is just 9, the square root of 25 is 5, so it's easier to take the square roots of these separately and then multiply the results. 33. Your work in the previous scenario should suggest the following properties. Part A. The square root of A times B is equivalent to the square root of A times the square root of B. Part B. The square root of X times the square root of Y is equivalent to the square root of X times Y. 34. Now consider a product such as the square root of 25 times the square root of 3. You can simplify the square root of 25 as 5, but you cannot rewrite the square root of 3. As a result, the most simplified form of the square root of 25 times the square root of 3 is 5, and then times the square root of 3, which we can actually write as 5 root 3. Without a dot there, the multiplication is still implied. 35. What is the most simplified form of the square root of 4 times the square root of 5? The square root of 4 is just 2, and then I can put times the square root of 5. I cannot simplify, so I can put 2 times root 5, or 2 times the square root of 5 without the dot for multiplication. 36. The expression 2 times the square root of 5 means 2 multiplied by the square root of 5. Another way to say this is 2 times the square root of 5. In order to make it easier to say, you can shorten this to 2 root 5. The expression 4 times the square root of 11 can be written out with words as 4 root 11. Write out each of the following expressions using only words. Part A, 5 root 3. Part B, 7 root 6. Part C, 4 root 10. 37. Simplify each product as much as possible. Part A, the square root of 4 times the square root of 3. The square root of 4 is just 2, so I can bring that down as a 2, times the square root of 3, because I cannot simplify the square root of 3. And I can remove the dot and just write 2 root 3. Part B, the square root of 9 times the square root of 2. I know the square root of 9, that's 3. The square root of 2 can't be simplified, so I can bring it down, and I can also remove the dot. Part C, the square root of 2 times the square root of 25. The square root of 25 is 5, so I can write this as root 2 times 5. And it is typical, just like when you have x times 2, it's typical to write that as 2x. We can do this in the same way. I can put the 5 first, and then root 2 next to it. That also means root 2 times 5. 5 times root 2, 5 root 2. Part D, the square root of 5 times the square root of 2. I can't simplify either of those, but we did learn that if you have the square root of two numbers multiplied separately, that you can write that as the two numbers multiplied together under one square root. And now we can see that 5 times 2, we can multiply that. That's 10, so the square root of 10. The square root of 5 times the square root of 2 is the square root of 10. I can write it like that. 38. In the previous scenario, 2 root 3 is the most simplified form of the square root of 4 times the square root of 3. You can use the property that the square root of a times b equals the square root of a times the square root of b to rewrite the square root of 4 times the square root of 3 as the square root of 4 times 3, which is also the square root of 12. This reveals that the most simplified form of the square root of 12 is 2 root 3. What is the most simplified form of the square root of 27? Well, let's think about numbers that can multiply together to make 27, and we want to pick numbers that are perfect squares. So in this case, 27 is 9 times 3. And I can use this property that if they're multiplied together under one square root, I can look at that as the square root of each number separately under different square roots and then multiply together. Now the square root of 9, that's just 3. And the square root of 3 I can't simplify, so I can just bring that down times the square root of 3, and then I can remove the dot and just put 3 root 3. So the square root of 27 is 3 root 3. Another way to state the previous result is that the square root of 27 has the same numerical value as 3 multiplied by the square root of 3. Part C. Since the square root of 12 is the same as 2 root 3, it follows that the square root of 12 is 2 times larger than the square root of 3. 39. Radical expressions are simplified below. Fill in the missing values in each scenario. Part A. The square root of 18. 18 is 9 times 2, so it's the square root of 9 times 2. I can separate it as root 9, root 2, and then root 9 is just 3. So 3 root 2. Next, part B. Root 48. 48 is something times 3. What times 3? It might take you a little while to figure this out, but 16 times 3 is 48. So I can write the square root of 16 times 3 as the square root of 16 times the square root of 3, and the square root of 16 is just 4. So root 48 is 4 root 3. Part C. Root 20. What numbers multiply to equal 20? I can do 20 times 1, but that wouldn't help me. 10 times 2, but neither of those is a perfect square. 5 times 4, 5 times 4, that'll work. So if I put a 5 here and a 4 here, I can separate them as the square root of 5 times the square root of 4. And, now how do I write this? Do I just bring the 5 here and then write that the square root of 4 is 2? Well, no, that doesn't really work because that's a root 2. This says root 2. I want to somehow say that the square root of 4 is 2. So let me just write 2. And then the square root of 5 is not 5, it's the square root of 5. So I need to still write it that way. Okay, so I have the square root of 5 times 2. That's fine, or I can write it where the 2 comes first, 2 root 5. So 2 root 5 is the square root of 20. Number 40, write down the first 10 perfect squares. They are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Why am I having you write them down? Well, when you're taking square roots and trying to simplify them, you need to be able to find perfect squares like 9 and 16 and 4. And if you know the perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc., it'll make it easier to do that. 41. What is the largest number that is a factor of the number shown and also a perfect square? Well, first let me write down the perfect squares down the side of the page up to 100. There's the first 10 perfect squares, and I'll go even farther. 11 squared is 121, 12 squared is 144. We can stop there for now. Now let's look at part A, 32. What's the largest number that is a factor of 32 and also a perfect square? Well, it can't be larger than 32. 36 is not a factor of 32, it's larger than 32. 25 doesn't divide evenly into 32. 16, let me think about that. 16 times 2 is 32. So 16 is the largest factor of 32 that's also a perfect square. Part B, 45. Now let's look at our list. Let's go with 49 can't be a factor of 45. It's larger than 45. So let's go below 45. 36 is not a factor of 45. 25, no. 16, no. 9, yes. 9 times 5 is 45. So 9 is the largest perfect square factor of 45. Part C is 500. Looking at the list of perfect squares, I don't go up to 500, but I know 100 is a factor of 500. 100 times 5 equals 500. And since 5 is a prime number, it doesn't contain any factors that are perfect squares. I can see that 100 will be the largest factor that's also a perfect square. There are larger numbers that divide evenly into 500, but they are not perfect squares. Part D, 192. Now you probably aren't familiar with the factors of 192, so let's just go through this list of perfect squares and see if any of these numbers divide evenly into 192. How about 4? You can use a calculator to see that 4 times 48 equals 192. Well, now let's look at 48 and think about factors of 48. Are there any numbers in the list of perfect squares that we have here that divide evenly into 48? Well, how about 4? 4 times 12 is 48. Now, how about this 12? Does 12 have any perfect square factors? It does. 12 is 4 times 3. Now look at all of these 4s that we have here. We have 3 4s that we found that are factors of numbers that divide into 192. 1, 2, 3. So that means 4 to the third power times that 3 remaining, this right here. 4 to the third power times 3 is 192. Well, what is 4 to the third power? 4 times 4 is 16. 16 times 4 is 64. So 64 times 3 is equal to 192. 64 is a factor of 192, and it's the largest perfect square factor of 192. Now I showed how to do this by pulling out small factors, looking at 4 dividing into 192, and then 4 divides into 48, 4 divides into 12. But you could also have divided 192 by larger numbers, and you would have found that 16 divides into it. Or you could have tested out 64 and found that it's a factor early on. It doesn't matter the order in which you go through this, but if you keep finding factors of this original number that are perfect squares, and then multiply those together, you can eventually get to the point where you realize the largest perfect square factor. 42. For the number shown, find all of the factors of that number that are perfect squares. Part A is 32. Let's go down the list from the smallest ones first. 32 is 4 times 8. 9 is a perfect square, but it doesn't divide evenly into 32. 16 does. 16 times 2 is 32. 25 is the next perfect square that it's less than 32, but it doesn't divide evenly into 32. So the perfect square factors of 32 are 4 and 16. Part B, 80. Let's start with small factors of 80. 4 times 20 is 80. Now let's look at 20. 20 is 4 times 5. So I'll write that below 20. And I can bring down the first 4. At this point, I can see that 4 is a factor of 80, and 4 times 4, which is 16, is also a factor of 80. And there are no other perfect square factors. Part C, 36. I'll start with the smallest one, 4. 4 times 9 is 36. Well, 9 is a perfect square. So there I see that 4 and 9 are both perfect squares and factors of 36. And there are no other ones. Part D, 288. Let's first see if 4 divides into 288. It does. 4 times 72 is 288. Now let's look at the 72. Does 72 have any perfect square factors? How about 4? 72 divided by 4 is 18. So 4 times 18. And then I'll bring down the first 4. Well, how about 18? 18 is divisible by 9. 18 is 9 times 2. Let's bring down the 4 and the other 4. Now let's look at these listed out factors. I can see 4 is a factor of 288. 9 is a factor of 288. 4 times 4 is 16. 4 times 9 is 36. Now let's check 4 times 4, which is 16. 16 times 9. Well, 16 times 9 is 144, and that's a perfect square. So now I have my list of all of the perfect square factors of 288. Now this is a process that could be challenging to do by hand, but I think it's a good thing to go through thinking about the factors of numbers that are perfect squares, even if it's a really large one like 288. And you could use a calculator and just go down this list, say 288 divided by 4. Does it work? Can I do 208 divided by 9? Do I get an integer? 288 divided by 16, divided by 25, divided by 36. You could just go down the list of these perfect squares and divide your number you're interested in by those and see if it works, if you want to use a calculator. 43. Simplify each expression shown by finding the largest perfect square factor. Part A is the square root of 20. In our list of perfect squares, 4 is a factor of 20, and 4 is a perfect square. So 20 is 4 times 5. Well, this is the square root of 20, so I'll write the square root of all of that. And we learned that the square root of 4 times 5 is the same thing as the square root of 4 times the square root of 5. The square root of 4 is 2, and then the square root of 5 can't be simplified, so I'll bring it down. So 2 root 5 is the square root of 20. Part B, the square root of 24. 4 is a factor of 24, and that's 4 times 6 would be 24, so I'll put the square root of all of that. I can separate that as the square root of 4 times the square root of 6. The square root of 4 is 2. The square root of 6 can't be simplified, so I'll bring it down. And then I have 2 root 6 as my simplified form of root 24. Part C, the square root of 28. 4 is a factor of 28. 4 times 7 equals 28. I'll put the square root over that, and I can separate those out. The square root of 4 times the square root of 7. The square root of 4 is 2, and the square root of 7 I cannot simplify, so I'll bring it down. 2 root 7 is the simplified form of the square root of 28.